So now we're going to be looking at the work energy theorem, how work relates into energy. So compare the kinetic energy of a 20,000 truck moving at 110 kilometers an hour per versus an 80 kilometer astronaut moving at 25. Okay, so here we're going to use the equation for kinetic energy. Kinetic energy is 1/2 mv squared. Kinetic energy is a scalar. Okay, so it's not a vector, it's just a scalar quantity. So we don't care about necessarily the direction the velocity vector is going, we just care about the magnitude of the velocity. So we do this kinetic energy. So let's do for the truck, his kinetic energy is 1/2 20,000 kilograms times v squared. Now, the velocity you always want in meters per second, so this is 110 kilometers per hour, and so we got to do our dimensional analysis. To convert this into meters per second, I want meters up here and kilometers down here. So it's 1,000 meters per 1 kilometer. And then I want seconds on the bottom. That means I need hours on the top to cancel that. 1 hour is 3,600. And all of that squared. So 110 times 1,000 divided by 3,600, and then square that. I would get 93. 1, 2, 3, 4, 5, 6. 9.3 times 10 to the 6 joules. Okay, so that's the energy of the truck. Now, the astronaut is much lighter, but moving way faster. 1/2 80 kilograms times 27,500. Again, we got to use the same conversion because this is kilometers per hour. So I'm going to times 1,000. Okay, so 0.5 times 80 times 27,500 times 1. I get 2.3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 joules. So way more energy. And that's because kinetic energy is proportional velocity squared. So velocity makes a bigger difference on the energy in kinetic energy. Confirm the value for kinetic energy of an aircraft carrier in table 7. You need to look up the definition. Let's delete this problem. Sorry, I didn't screen that very well. Okay. A car's bumper is designed to withstand a 40 kilometer an hour collision with an immovable object without damage to the body of the car. The bumper cushions the shock by absorbing the force over a distance. Calculate the magnitude of the average force on a bumper that collapses 0.2 meters while bringing a 900 kilogram car to rest from an initial speed of 1.1 meters per second. Okay, so what this has to do is the fact that a car is going to stop, and in order to stop, it has kinetic energy because it's moving, and then has no kinetic energy because it's stopped. And the work energy theorem says that work must have been done on the car in order to change its kinetic energy. So first, let's start with the energy of the car, or the change in energy. Because the energy goes from some velocity to not, it must have lost energy in the form of the kinetic energy. Now the 1/2 mv squared, so this is 1/2 900 kilograms and then 1.1 meters per second squared. Okay, this is the initial energy of the car. It is 544.5 joules. Now, in order for this energy to have disappeared, something must have done work on the car in order to reduce all of its energy to 0. So the work done on the car must equal the force by the car times the distance. Okay, like the definition, just like we've been doing in the previous problems, force times distance. Now, this has to equal 544.5 joules. Otherwise, the car shouldn't be stopped. All the work must be done in order to do this. So the force is equal to the energy divided by the distance. The distance in this case is how much is the force that the bumper is being applied over whatever distance. And the distance is it collapsed 0.2 meters. And that's because it's the bumper that's pushing to slow the car, right? Because the bumper's crashing into something. The bumper is exerting work onto the car, And it's doing that for a distance of 0.2 meters. So that would calculate the force. And so that is 2,722.5 newtons. Okay? So that's how the work energy theorem works, is the work done on the object must change the kinetic energy of that object. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.